Hey everyone! Today we're diving into the fascinating world of chemical potential energy, heat, and energy changes in chemical reactions. Let's start with chemical potential energy definition. It is the stored energy in matter because of its structure. Essentially, it's the energy waiting to be released during chemical reactions. Heat, on the other hand, is the energy transferred from hot to cold objects. We measure heat in calories, which is the energy needed to raise 1 gram of water by 1 degree Celsius, or in joules, the SI unit. Now, let's talk about heat content, or enthalpy. The change in heat content during a chemical reaction is the amount of energy absorbed or released in a chemical change. It's calculated as the enthalpy of the products minus the enthalpy of the reactants. This value tells us whether a reaction releases or absorbs energy. Reactions can be either exothermic or endothermic. Exothermic reactions release heat, so enthalpy is negative. Examples include combustion reactions or a hot compress. Endothermic reactions absorb heat, making enthalpy positive, like decomposition reactions or a cold compress. Next, let's look at changes of state. Heat of combustion is the energy released by combustion of 1 mole of substance. Heat of fusion is the energy needed to melt 1 mole of a solid. For water, H2O solid to liquid, it's 6.01 kilojoules. Heat of vaporization is the energy needed to vaporize 1 mole of liquid. For water, H2O liquid to gas, it's 40.7 kilojoules. Heat of solidification is the energy released when 1 mole of liquid freezes. Heat of condensation is the energy released when 1 mole of gas condenses. Remember, fusion and vaporization are endothermic, while freezing and condensation are exothermic. Also, the heat of vaporization equals negative heat of condensation. Hess's law states that regardless of the number of steps in a reaction, the total enthalpy change is the sum of all the individual changes. The standard heat of formation is the heat change when 1 mole of a compound forms from its elements under standard conditions. For elements in their natural state, this value is 0. Finally, the standard heat of reaction is calculated as the sum of standard heat of formation of products minus the sum of standard heat of formation of reactants. And that's chemical potential energy and heat. Understanding these concepts helps you predict how reactions behave and how energy flows. Keep studying and you'll master it step by step.